Hello, this is Scholar Strack doing some math today in geometry. We're going to prove triangles are similar by SSS and SAS. So this is called the SSS triangle similarity theorem. So SSS with a squiggly. You don't want to be confused with the SSS we did last semester, which is the side-side-side congruent triangles theorem. So this one shows. This one is about similarity. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So once again, if we had two triangles here, that's short side, long side, that, short side, long side, that. So let's say 4, 10, 15. 10, 20, 30. So if AB over DE is equal to BC over EF, which is equal to CA over FD. So this is ABC, DF. So if the side lengths are proportional, then they are similar. So if all the sides. And we can also do SAS. So if two sides are proportional and then the included angle is congruent, then the triangles are similar. So this is what happens if we did something like this. So we had this angle be the same as this angle, and this is 4. Let's have this be 2. Let's have this be 8, and then have that be 4. So these would be similar because the two sides are proportional to each other, and the included angle, the angle in between, is congruent. Alright, let's find out if any of these triangles are similar to each other. So we need to check all the sides because they don't give us any angles. So let's look at AB over DE. I'm going to compare the two left triangles, or the two small triangles. So AB to DE is 8 over 4, which is 2 over 1. BC over EF, that's equal to 8 over 6, which is 3 over 2. So not similar. So ABC is not similar. So you just drew a squiggly with a line through it. Triangle DEF. Okay. So triangle 1 and 2, not similar. Let's try the right two triangles. Middle so triangle, let's call this 1, 2, 3. So let's try 2 and 3 combination. So DE over GH, that's equal to 4 over 16, which is 1/4. Let's try EF HJ. So the corresponding sides should be proportional, and they should be equal. 6 over 18 is 1/3. So 2 and 3 are not similar. So triangle 2 is not similar to triangle 3. So all we have left is now 1 and 3. So AB over GH, BC over HJ. Okay, we got 8 over 16, that equals 1/2. We got 9 over 18, that's 1/2. So that means we should test the last side, because these match. So we need to check the final side. CA over JG. 12 over 24, that's 1/2. That means triangle 1 is similar to triangle 3. Now, you wouldn't call it triangle 1 and 3, you would call it triangle ABC and triangle GHJ. And that is by the SSS similarity theorem. Alright, example 2. Find the value of x that makes ABC similar to triangle DEF. Okay. So, we need to find an x value here. So let's create a proportion. I'm going to say left side of small over left side of big is equal to right side of small over right side of big. So x minus 3 over left side of the big, which is 20. Right side of the small is 4. Right side of the big is 10. So when first I'm going to reduce this. So this is x minus 3 over 20. And that's equal to 2 over 5. When I cross multiply, I'm going to get 5 times the quantity x minus 3. So be careful when you're doing your cross multiplication. And then 20 times 2 is 40. Okay, I'm going to distribute and get 5x minus 15 equals 40. So 5x equals 55. So x equals 11. Okay, example 3. Tell how you would show that the triangles are similar. So they already give us this intersection. Whenever you see an intersection, just put your congruent angles there because they help a lot. And we're going to use SAS similarity theorem in order to do this. Probably because 18 over 24, so the big side of the left triangle over the big side of the right triangle is equal to small triangle over left, or over left triangle over right triangle. And let's see if that's true. This is, if we reduce this, this is this is 3 over 4, and this is equals 3 over 4. So that means the sides are proportional. So we have the two sides and the angle in between. Angle PRQ is congruent to angle SRT. Alright, so we want to know that if the left triangle is similar to the right triangle, how do we show that? This one, we would have to show that all three sides are proportional. So JL over LM. JL is the long side of the left triangle. Long side of the right triangle is LM. So that is 56 over 32. So that reduces down to 7 over 4. Okay. Now we're going to do the height of the left triangle over the height of the right triangle, which is actually, or you can think of it this way. So if I look at the two triangles here, so if you look at these, I'm using LK here. This is the short side of the left triangle. So the short side of the right triangle is KM. Okay. So this is 28 over 16. And this is 7 over 4. And then we do the last remaining side, which is the long side. Well, not the longest, but the second longest side of the left, which is JK, over LK, which is the longest side of the right triangle, or second longest. 49 over 28 equals 7 over 4. So all corresponding sides are proportional. So SSS similarity. Okay, and then just a reminder of the theorems. We have AA similarity. If two of the angles are congruent, then the triangles are similar. If all three sides are proportional, then the two triangles are similar. And then lastly, if two sides are proportional and the included angle in between is congruent, then the triangles are similar. Hopefully this helped you out. Have a good day.